Okay, we're on AP Calculus, Unit 7, Day 58, Part 2. So what we're going to do, we're going to get into the second fundamental theorem of calculus. Okay, so the second fundamental theorem of calculus says if I have f of x, and I'm taking the integral of f of t dt, and my interval is from a to g of x. So a is a constant, g of x is some function. Well, all I can do is to go from f of x, which would be the antiderivative, and then I take the derivative of that. So, and this only works when I'm trying to find the derivative, and we just got to pay attention to that. Okay, and we could do it the long way like we just did, and that's fine, but this is just a shortcut. Okay, and the shortcut says, hey, take your f, whatever your outside function is, take g of x, put it inside, but then at the end you have to multiply by the derivative of that upper interval. Okay, so it's kind of similar to what we did with chain rule. Okay, and I kind of went through and explained this already from the previous page, but I'll just write it up again just so we can see it. So for all four of these examples, we already know what the derivative is from our original answers, but then we're going to go kind of what I explained. We're going to go through and say, okay, well, let's use the second fundamental theorem of calculus, which says take this, put it into the t, so, and that's going to give us our derivative. So capital F prime of x is equal to 4x. So we go through, we put an x in, we get 4x minus x squared, and then we multiply by the derivative of the upper interval. Derivative of x is 1, and we get the same answer. So capital F prime equals 4x minus x squared, which just saves us a couple steps. Instead of doing the fundamental theorem of calculus, simplifying, and then take the derivative, the second fundamental theorem of calculus just says, hey, if it's in this format where there's a function up here, you can skip to the shortcut. All right, let me write the next few down. Okay, so we put every place I see a t, I put it in the upper interval because it's a function, x. We get cosine x, then I multiply by the derivative of that upper interval. Cosine x times 1 is just cosine x, which is the same as the answer that we got before. Okay, so I put the x squared in every place I see a t, because again, that's what our second fundamental theorem of calculus was. So we leave this lowercase f of t, and we put in the g of x inside, so it's x squared all cubed, and then multiply by the derivative of what was inside, which is the upper interval, 2x. X squared all to the third is x to the 6 times 2x, and that equals 12x to the 7th, which is what our answer, oh, sorry, not 12, 2. Sorry about that. 1 times 2 is 2. 2x to the 7th, which is the same answer we got up here. All right, we got a 12 down here. Let's do this. So we're going to take the x squared. Every place you see a t, I'm going to put it in. So it's 6x squared, and then times the derivative of that function that was the upper interval. Square root of x squared is just x, so 6x times 2x, and then we're going to get 6 times 2, there's my 12, 12x squared. So again, anytime we have a constant, and the upper constant is the lower interval, and a function as the upper interval, I can use the second fundamental theorem of calculus. Okay, so let's go on to the next page. Why don't you guys try them, and I'll fill them out, and then check your answers. And we should just make sure they ask us to find the derivative of those, because if they don't ask you to find the derivative, then you're not going to use the second fundamental theorem of calculus. So we take the 2x, we put it in every place you see a t, so we get square root of 2 minus 2x all squared, and then times 2 at the end, because that's the derivative of the upper interval. And then we can just rewrite it as 2 times the square root of 2 minus 4x squared. We can't simplify that. All right, let's do the next one. Okay, the first thing we have to do here, the function is at the lower interval, so we have to use our properties of integrals and make it be the opposite, and then switch our intervals. So now we have it set up. We can just take the upper interval, put it into t, and so we get negative, because that was out front, e to the cosine x squared times 2x. And now we can't do anything else with that, so we just simplify it. By simplify, rewrite it with the 2x out front. All right, let's do the last one. It's already set up for us, so we don't have to change it. So we take the upper interval, put it into the t, so now we get, and I'm just going to rewrite it, sine then cosine, but actually it doesn't matter. I'll put the highest power, but I do have to put the negative out front. So let's do that. And we get negative cosine squared x times sine x. So now this just becomes a part of what we can do based on the information we're given. Okay, so we kind of got to pay attention to, like on these next couple problems, find f of 0. Hey, just put 0 in and see what we get. So first of all, this is the graph of g of t. So when they want to find f of 0, I'm just going to put in what I know, and it's the integral of g of t dt, and it's 2 times 0, which is going to be 0, and then the negative 4 stays here. So again, negative 4 to 0 of gt dt. What does the integral stand for? It stands for the area under the curve. So now I'm going to try to find the area of the curve from 0 to 4. Okay, so in the red, I have a quarter circle with a radius 2. So that's going to be 1/4 pi r squared. And the radius was 2, so it'll be pi 2 squared. Then we're going to add to that the blue, which is a rectangle, which is 2 by 1. And so 2 times 1. And then hopefully with the green, we notice that it's exactly the same triangle above the x-axis as it is below. So plus 0. So now we can write this as our final answer. So this is 1/4 pi times 4, which is just going to be pi. So we're going to get pi plus 2. Okay, remember the area above the x-axis is positive, area below the x-axis is negative. And now we need to do the same exact thing for number 2. Okay, so now when I put a 2 in, that's negative 4 to 4. I should notice as I go from here over that they're symmetric from negative 4 to 4. So everything I found over here will be over on this side. So it's y-axis symmetric. So it's an even function when I go from negative 4 to 4. So now all I got to do is take the answer I just found, pi plus 2, and multiply by 2. And we get 2 pi plus 4. So number 3, they asked for f prime of 1. So the first thing I have to do is find f prime of x, which is going to use the second fundamental theorem of calculus, which is going to take this 2x and put it in there. So I'm going to get g of t, that's my outside function, but I'm going to put the upper interval into the inside function, and then I'm going to multiply by the derivative of what was outside. Okay, so we can rewrite this as 2g to the 2x, but now I can put in my 1. So what I did here was just, again, every place in x I put in 1, 2 times 1 is 2, and now when it says g of 2, I'm actually coming into, because this is the graph of g of t, I'm actually finding out what the y value is, and it's 1. So now this is going to become, and this is what our answer is, 2, which was at the end, I just moved it up front, times g of 2, which is 1, so the answer is 2. Okay, we have to do the same thing on number 4, and we already have the first part set up. Okay, so I know the derivative equals 2 times g of 2x. So then let's find the derivative when x equals negative 2. And so when I put that in, I'm going to get 2 times g of negative 4. Let's go up to the graph. Where am I when I'm at negative 4? I'm at negative 1. So now I know 2 times negative 1, which is just negative 2. And that's my answer. Okay, and then on number 5, it says take the second derivative. Well, how do I do that? Well, let's use what I know for the first derivative, and then take the derivative of that. Okay, so how do I take the derivative of this, which is the second derivative of the function? So it's the derivative of the first derivative. So we're going to use the chain rule. So leave the outside the same, And again, the constant just carries along. So we take, we take the derivative of the outside, so it's g prime, leave the inside the same, and then multiply it by the derivative of what was inside. Okay, so now this 2 times 2 is going to become 4. So now we're going to get 4 g prime of 2x. Every place I see an x, I'm going to substitute in 2. So it's going to be equal to 4 g prime of 4. So in order to get this answer, I have to go up to my graph, which is a graph of just g of t, and I need to see, hey, what's the derivative at point 4? So what's the slope of the tangent line? So let's go up and look at that. Oh, here's 4 right here. Ooh, that's the end point. So it's not continuous over here. So obviously if it was up here at 3 or up here, I can't do it at corners, but I can't take the derivative at this endpoint. So we know f double prime of 2 is going to be undefined because g prime of 4 does not exist since g of t is not continuous at that point. Let me write that out right now. Okay, so that's it for Unit 7, Day 58, Part 2. Let's take a look at some of these last few problems as some practice for Part 3.